Hello everyone, I'm Paul and today we're solving problem 368, largest divisible subset. We are given an array nums and we want to return the largest subset such that every item in the subset is divisible. So let's see what this means. Let's say we have this array 1, 2 and 3 and 2 is divisible by 1. So we can have a subset with 1 and 2, and 3 is divisible by 1 also, so we can have a subset with 1 and 3. We can return either this array or this array. So here it says that we need to consider every pair that satisfies answer at I modded by answer at j equals 0 or answer at j modded by answer at I equals 0. So we can forget about some part of the logic just by sorting this, okay? So let's say we get 3, 2, and 1 as our initial array, and the first step would be to sort this. So we'll have 1, 2, and 3. Just by doing this, we can forget about this part and only focus on this one. Down here we have some constraints. For example, num's length will never exceed 1000, and what this means is we can't implement a solution if in big O of 2 to the power of n. So we can't use something like backtracking, for example. We need to think about something faster, and luckily we can use dynamic programming, and specifically we will use bottom-up dynamic programming. We will have 2 pointers, so we'll have a nested for loop, so our time complexity will be big O of n squared, okay, which is faster than big O of 2 to the power of n. Now let's go with an example. Let's say we have our sorted array over here, which is 1, 2, and 3. And we also want to create our DP array with the same values. So initially we'll get 1, 2, and 3. And each of these values will be inside a nested array. So as we said before, we are implementing bottom-up dynamic programming. So let's say our I pointer is here and our j pointer is over here. Well, initially we want to say if nums at index j 3 modded by numbers at index I, in this case 2, equals 0, in that case we want to take all the values at index j and add them to our array at index I in our DP. Okay, so let's go step by step. Here we want to check if 3 modded by 2 equals 0, which it doesn't. So we will keep this value in our array as it is, and we will keep moving. Now the I pointer is here and the j pointer is here, and we are checking if 2 modded by 1 equals 0, which it does. So we are taking all the values at our index j and we are adding them to the array at our index I. So here we will have 1 and 2. Now we keep moving and our j index is here. So we are checking if 3 modded by 1 equals 0, which it does. So we can take all the values at index j and add it to the array at index I. So here we could also get 1 and 3. And this would be the end of this DP array. Both of these subsets would be the bigger ones. So we can return any of these 2 subsets. Okay. Now let's go with a second example. Let's say we have 1, 2, 4, and 8. This is our sorted array. we are creating our DP and we are iterating in reverse order. So in this direction, our I pointer is here, our J pointer is here. 8 modded by 4 equals 0. So we add this 8 over here. Now I is here, J is here. So we are checking if 4 modded by 2 is 0, which it is. So here we'll have 2, 4, and 8. And we continue. Now I pointer is here and J pointer is here. We are checking if 8 modded by 2 is 0, which it is. So we'll get an array with 2 and 8, which in this case it has a smaller length than the array that we already have, so we keep this one and we continue. Now the I pointer is here, J pointer is here. 2 modded by 1 is 0, so here we'll get 1, 2, 4, 8, and we continue. Now J pointer is here. We are checking if 4 modded by 1 is 0, which it is, so here we'll get 1, 4, and 8, which has a smaller length than our current array, so we continue. Now J is here. We are checking 8 modded by 1 is 0. Yes, it is. So here we'll get 1 and 8. And this array is also smaller than our current array. So we end the loop. And this is our final DP array. And this is the array that we are returning. Okay. So we'll start by saying n is equal to the length of nums, and we will sort our nums. Now we want to create our DP array, so DP equals, for each value we want to create a nested array, so this for x in nums, and we'll say our result is an empty array. Now we want to iterate nums in reverse order with 2 pointers, so for I in range n -1, -1, and -1, and for j in range I +1, and here we'll say if nums at j modded by nums at I equals 0, we'll have the values at our DP at j plus nums at I, and we're trying to concatenate this, so this will be inside an array, and we can say this is our current array. And why are we putting this here? Well, because if this array is smaller than the one we have, we want to keep the one we have. So DP at I equals current if the length of current is bigger than the length of DP at I. Else we want to keep our DP at I. And finally here we can do the same with the result. If we get a bigger subset, we want to use that subset for our result. So result equals DP at I if the length of the DP at I is greater than the length of our current result, else we keep our result. Finally, we return this, and I guess this is it, but let's see what happens. And it does work. So if you found this useful, please drop a like, subscribe, and see you next time. Bye bye.